Ever wondered how scientists determine the purity and composition of a substance? It's a fascinating realm of chemistry, where the invisible becomes visible and the unknown becomes known. Today we're diving into the world of chemical characterization, exploring physical, analytical, and chromatographic methods. From melting points and optical rotation to high-resolution spectrometry and gas chromatography, we'll unravel the mystery behind these techniques. Join us on this journey to understand the fascinating world of chemical characterization. First stop, physical methods. These methods rely on the physical properties of a substance. Now let's dive into the world of physical characterization. Melting point and boiling point are two fundamental physical properties that can tell us a lot about a substance's purity. A pure substance will have a specific, sharp melting point and boiling point. Any impurities can cause these points to deviate, giving us a hint about the presence of alien particles. For instance, the melting point of pure water is 0 degrees Celsius. If the water you're testing melts at, say, -1 degree, it's a clear indicator that something's off. Next up, optical rotation. This technique is like a secret handshake for molecules. It's used to identify their structure based on how they rotate the plane of polarized light. Each molecule has a unique way of interacting with light, and by studying this interaction, we can infer a lot about the molecule's structure. It's a bit like molecular fingerprinting, if you will. And then there's refractive index, a property that describes how light travels through a substance. It's like the speed limit for light in a particular medium. When light enters a substance from air, its speed changes, causing it to bend or refract. By measuring the angle of refraction, we can determine the refractive index, which can be a telltale sign of the substance's identity. So, in a nutshell, physical methods of characterization are all about studying a substance's interaction with heat and light. These methods provide us with some initial clues about a substance's purity and structure. But for a more thorough analysis, we turn to analytical methods. So buckle up and stay tuned as we delve deeper into the fascinating world of chemical characterization in our upcoming scenes. You won't want to miss it. Analytical methods offer a more in-depth look at the elemental composition of a substance. They are akin to the magnifying glass of a detective, revealing the most minute details that the naked eye might miss. Take combustion analysis, for instance. It's a method that shines a spotlight on the elemental composition of a substance. Imagine you have a mystery sample. You don't know what it's made of, but you're eager to find out. Combustion analysis allows you to burn that sample in an excess of oxygen. What's left are simple compounds like carbon dioxide and water, which can be measured. From here, you can calculate the percentage composition of the elements in the original mystery sample. It's like solving a puzzle, one piece at a time. Then we have high-resolution spectrometry. This technique is like having a superpower that lets you see the unique fingerprint of each element. Every element in the periodic table absorbs and emits light at specific wavelengths, creating a unique spectrum. High-resolution spectrometry allows us to observe this spectrum and identify the elements present in a substance. It's like having a secret decoder ring that can translate light into the language of elements. Finally, we move on to relative molecular mass. This is the sum of the atomic masses of all the atoms in a molecule. It helps us understand the size and weight of our substance on a molecular level. This is crucial because the size and weight of a molecule can influence how it behaves and interacts with other molecules. Analytical methods give us a detailed snapshot of the elemental composition of a substance. But to understand how these elements interact and behave, we use chromatographic methods. These are the next step in our journey to understand the intricate world of substances. So stay tuned as we dive into the fascinating world of chromatographic methods next. Chromatographic methods help us understand the behavior of substances. And that's not just a clever phrase, it's the heart of chromatography. Let's dive deeper into this fascinating world, shall we? First up, we've got thin layer chromatography, or TLC, and its high-performance sibling, HPTLC. These techniques are like molecular detectives, helping us track down and identify the components within a mixture. Imagine a race where each participant runs at a different speed based on their unique characteristics. That's what happens on a TLC plate. The different components in a mixture travel at different rates, allowing us to separate and identify them. HPTLC is simply a more refined version of TLC, providing better resolution and shorter analysis time. Next up, meet high-performance liquid chromatography, or HPLC. This method is like a molecular sieve, separating components based on their affinity towards the stationary phase. Picture this: a busy highway with cars zipping past at different speeds. The faster ones are less attracted to the road, just as in HPLC, where components that interact less with the stationary phase move faster. This technique is particularly useful for separating components that are similar in polarity and molecular weight. Finally, we arrive at gas chromatography, or GC. This technique is a hot favorite for volatile substances. It works like a charm for separating components based on their boiling points and interaction with the stationary phase. Imagine a game of musical chairs where the one left standing is the component with the highest boiling point, taking the longest time to pass through the column. Now, how do we use these methods to determine purity? Well, a pure substance in chromatography would result in a single spot or peak. The presence of more than one spot or peak indicates a mixture of substances. So, in essence, these methods not only help in identifying the components of a mixture, but also in establishing purity. Chromatography is like a molecular dance, where each substance has its rhythm and pace. Some move fast, some slow, but each leaves behind a unique signature, a chromatogram, which we can read like a molecular fingerprint. It's a beautiful symphony of scientific principles working together to unravel the secrets hidden within substances. Chromatographic methods provide us with a comprehensive understanding of a substance's behavior and interactions. But how do all these methods come together? Well, that's a story for another day. Stay tuned. Each of these methods plays a crucial role in characterizing a substance. Let's take a moment to step back and look at the bigger picture. This isn't just about running tests in a lab, it's about understanding the very essence of a substance, from its basic building blocks to its behavior under different conditions. Physical methods like determining melting and boiling points, optical rotation, and refractive index give us an initial overview. They're like the cover of a book, providing a basic understanding of the substance. It's through these methods that we can infer a substance's state, its optical activity, and how it interacts with light. But what if we want to dive deeper? That's where analytical methods come in. This is where we get into the nitty-gritty, the elemental composition of a substance. Methods like combustion analysis and high-resolution spectrometry are akin to prying open the book and scrutinizing each word, each letter. They reveal the elemental composition, the very building blocks that make up the substance. Finally, we turn to chromatographic methods. These are our fine-toothed combs, our magnifying glasses. Techniques like thin-layer chromatography, high-performance liquid chromatography, and gas chromatography allow us to separate, identify, and quantify the components of a mixture. They give us a detailed understanding of the substance right down to its most minute components. Each method complements the other, creating a comprehensive understanding of the substance. Take, for instance, the process of drug discovery. Physical methods might be used to understand how a potential drug interacts with light, analytical methods could reveal its elemental composition, and chromatographic methods could separate and identify its components. Each step, each method, adding another layer to our understanding. Together, these methods paint a detailed picture of a substance from its elemental composition to its behavior and interactions. They are the tools that allow us to explore the world on a molecular level, to investigate and understand the very fabric of our universe. So, the next time you see a simple substance, remember, there's likely a fascinating story behind it, told through these methods of characterization. Chemical characterization is a fascinating field that combines various methods to understand the world around us. Today, we've journeyed through its riveting landscape, exploring physical methods like melting and boiling point determination, optical rotation, and refractive index. We've delved into analytical methods, discovering how combustion analysis and high-resolution spectrometry help determine elemental composition and how relative molecular mass is established. Our expedition took us further into the realm of chromatographic methods, where we learned about thin-layer chromatography, high-performance thin-layer chromatography, high-performance liquid chromatography, and gas chromatography. These techniques are not just theoretical concepts. They form the backbone of numerous fields, from pharmaceuticals to environmental science, shaping our understanding of the world. Yet we've just scratched the surface of this intriguing world. There's so much more to explore, to learn, and to marvel at. So come along on this scientific voyage, subscribe for more because you won't find me later.